Okay, so now we can move on to the discussion session. So there's some talks in the Q&A. Let me just go back. Let's see, the first question. Was already, oh no, that was already. No, wait, sorry, I'm having trouble with the accessing the questions here.
All right, so while Donald's getting that figured out, I'll step in. So I think the first one we had was from Charles Radley, and this was for Brad Jones. What are the dimensions of this the Dalek?
Oh, all right, sorry, I went through that really quickly. The footprint is about 10 by 12 centimeters with a height of about 50 centimeters. It weighs about 5 kilograms. We can probably get that weight down if we did some more thermal modeling to control the thermal waste of the microwave source. But right now, we're just kind of assuming that the waveguide and collector is going to be made out of aluminum.
All right, and Brent, there's one more question for you from Gerardo Dominguez, who asks, do you have a sense of what the collection efficiency is of using the microwave horn to collect water from regolith light samples?
Yeah, that it's got to be pretty high. So I would estimate at least around 80%. And that kind of depends on how good of a contact it's making with the regolith as well.
Okay, I'm all good on the questions. I already have them up. So I can take over. Let's see, the other question is, it was by Paul Lucy about the density range. So I actually don't remember what per cc stands for. Paul, do you want to just go ahead and ask the question?
I think Paul might be on mute, but it's
that was for Medi. I saw your density range on the slide, and I couldn't tell if it was 1 particle per cc or 1 to the 13th per cc was the range.
Yeah, it's the full dynamic range of the instrument goes from 1 particle per cc to the 10 to the 13th per cc.
Okay, great, thank you.
All right, let's see. So we have another question from Alien. To the last speaker, what was the active Raman spectroscopy you used? Gordon?
Oh, please. I think Dina may be on the line, and she may be the best person to answer that question. Dina Bauer?
I think she replied, says the Rockstar package on Corgi uses both Viz 532 nanometers and near infrared 785 nanometers.
Yes.
Okay.
Thank you.
Okay. Let's see. No, looks like there's no. Well, it looks like there was one. Let me see who this was for. It was the question about what's the thermal power source batteries for radioisotopes. I think that was for Medi.
So the system runs purely passively. It's a combination of thermal blankets, radiators, and power management for operation during day and night. If you balance everything right, that's why we have a lot of constraints on what operates when, and for things that operates for long duration, how much they can dissipate at what time. It's if you balance things right, you basically can close that thermal design passively.
Okay, is there any other questions? We already have time for one more.
Yeah, I am. This is Tom Orlando. I had a question with the mass spec and the LET detector. It's good to combine those, but the mass spec is notorious for spurious counts with X-rays and things of that sort. Are you able to discriminate against those, since you would maybe be able to do some coincidence measurements?
So yeah, we believe so. I mean, it has to be extra looked into it. But for example, on the space station, we have sub-hertz noise from the instrument, and we measured 16,000 channels. So it's really, really low noise from radiation.
Okay, thank you.
Okay, so I think that's all the time we have for questions. So yeah, it was really good. Good job, everybody.